as Conrad said, I'm the program manager of open source science. OSI is a initiative out of NumFOCUS that's trying to bridge the gap between open source developers and open source research software and the users of that research software. So I'm sure you know, there seem to be some bugs in the open source research software stack. Tim, it does look like you have an echo. Mute maybe. Awesome. Wait, is this still echoing? We'll keep going. We'll see what happens. So there seem to be some bugs in the open source science stack for research software, where, oh man, where to even start? If you're a researcher, for example, and you just want to do one simple thing, you're presented with this ecosystem of just so much software to choose from that it's kind of overwhelming. And oftentimes you'll end up just building your own tool, your own software to do a very specific thing for your research, when in reality, you could have just probably built a little edit into some research software that already exists with the support of a giant community behind that research software that already exists. And the result of this problem where people are creating their own professorware maybe is that you get some really cool software that just dies as soon as the person who created it in the first place for their very specific use case moves on to either another institution, another project, or just doesn't have time anymore to support that research software. So that's just one example of one of the bugs that might be in the open source research software stack. So our hope at OSI is by connecting the wide ecosystem of open source research software directly to researchers, we can prevent that problem and many others, and at the same time give a lot of added value to researchers and developers of open source research software along the way. So maybe you can think of it like product discovery or user experience discovery or user feedback in a simple way. And one of the ways we want to do that is through MOS. The map of open source science. There are other ways we're doing this as well. There are a bunch of interest groups we have that you're very welcome to join. If you email me, I will connect you to all those, or go to that QR code. I think that will link you to the MOS interest group only, but there's one in chemistry, life sciences, climate and sustainability, reproducible science, and that's all that comes up at the top of my head, but there are a couple more as well. But MOS is let me just show you. Okay. So disclaimer before we begin this little demo of what we're building here. This is a very early proof of concept. We're just trying to experiment with what's possible when it comes to visualizing the open source software research software ecosystem in a graph visualization. So there's going to be data in here and information that we've just put in as placeholders. There's going to be some information data that's not 100% accurate, but kind of accurate. And just keep that in mind as we're going through it. But let's start with this. So this is the open source research software ecosystem around only NumFOCUS. These are NumFOCUS projects and NumFOCUS peoples that we've mapped. So this is barely a tip of the iceberg, although NumFOCUS does officially sponsor many open source research software projects. The little orange dots, let's zoom in a little bit. The little orange dots, you can see down here is the key, are packages. Green dots are people. The red dots are projects down here. Yellows are papers, and I think we added our first paper, though I'm not sure if this version of the map is updated. And then the orange dots are organizations. And it does look like this map is updated, so we get to explore the paper route for the first time today, I think. But this is crazy. If you're a researcher and this is essentially a visualization of the ecosystem you enter when you're trying to figure out what tool to use or who to reach out to help you build some software to do your research. So the goal is to simplify that process, and we can walk through a couple stories about how that might work. And for the sake of my computer, because this is all processed locally, I'm going to remove people from this map so we don't freeze. So I'll add it back later so we can hopefully, as long as my computer doesn't crash when I do it, visualize the entire ecosystem map and all the connections and everything. But right now we're just looking at organizations, packages, and projects. Here is NumFOCUS. When you click one of the nodes, you can see the information that we populate the map with. All of this is graph information. All of this is inputted fields about any project and package. So let's just see what it looks like when we map all the fiscally sponsored projects to NumFOCUS. And you can already see sort of where this is going to go. So NumFOCUS is the fiscal sponsor to all of these projects. NeBabel, NumPy, you get all the information here, the little blurb, and then essentially a database right here. And this database is going to end up getting very complicated very quick, very text heavy very quick, which is why we think a visualization is going to be very helpful. So let's say we are a researcher entering the machine learning space for the first time. And we want to know what possible tools, like we know nothing about what tools exist for us to use, and we want to learn what possible tools we could use. And then if we want to learn more about these tools, who we can reach out to or what organizations we can reach out to. So let's remove fiscal sponsors. And please don't yell at me about ontologies. We had to make some decisions about what is what's here. But let's map every project that deals with a field of science. We've mapped it currently into subdomains, subfields, and domains. So you can see this big orb right here, data science, and another disclaimer, the metrics we're using to visualize the size, which correlates to the importance of various packages and projects. And people are very inaccurate. They're the easiest numbers we can find currently. But we've got now a bunch of subfields here. And we can search for machine learning. Here's the machine learning subfield. And let's focus only on that subfield because as a researcher, that's what we're entering this field. That's what we're interested in. Let's show the names. And there we go. With a couple clicks, we now see several projects that we should probably explore if we want to start looking into machine learning and the tools that we can use for this. Now, we want to go a little deeper, so let's see if we've mapped any packages of these projects. Like we have not. But once we do, you'll be able to see all the packages and get a little deeper into each one of these projects that are related. But maybe we have mapped some complementary tools that are used often in conjunction with these. Oh, you know what it is? I need to expand my focus. There we go. So we've got machine learning here. We can go down to, this one looks easy to read, PyTorch, and we can see that all of these tools are also complementary to PyTorch. So maybe if I want to start using PyTorch as my primary tool, I should look at these more granular tools as well. So you can start to see the process here, and you can expand even further. You can get more in detail, more in depth with just whatever you want to do. And it starts to get very noisy for a specific use case, but very cool for a visualizer very quickly. So we'll stop here. There's another interesting use case with the map. Let's remove all the connections. I'll go over with really quickly. Let's remove our focus, and we're back to that base map. Let's say we have found a security flaw with matplotlib. So we're going to find, and we need to figure out who to let know about the security flaw and what else might be affected by the security flaw. So now we have matplotlib as our focus. And we know that fiscal sponsors are generally speaking good people to reach out to, good organizations that support the projects and can give us a little more information about this. And we won't be bothering the core development team or the maintainers of this open source project at the same time. So right away, we can see that we're going to reach out to NumFOCUS to talk to them about the security flaw really quick and get some guidance on what we should do with it. And here's other information, etc. That's awesome. That was very quick. Now, let's say we're a large organization or institution, and we want to figure out, in worst case scenario, what is going to be affected by this security flaw. So we're going to map the dependencies related to map.lib. And this constant moving is a feature of the software we're using to build out this proof of concept. It's called Kumu. Kumu is really cool for a graph visualizer, by the way. Would recommend checking it out. But we've mapped the dependencies now, and we can see that all of these projects are dependent on matplotlib. So if there is indeed a critical flaw in matplotlib, which there is not, but in this scenario we're saying there is, then we're going to have to explore the effect on all of these other projects and whether or not we can continue using them. Now, let's say, whoops, go back to matplotlib. Now, let's say there is a critical flaw in it, and we need to figure out what we can do, because we need to keep using, applying the features of matplotlib, but we can't use matplotlib anymore, applying the utility of it. So we need to find out what else we might possibly use to get the same utility. So let's map the alternatives. Freeze the map, and here we go. We see that it's possible that some of these projects do similar stuff to matplotlib. So these are projects worth exploring, maybe reaching out to their fiscal sponsors. They might know a little more about what might be a good alternative. See now which ones are lib again. Let's just go back here. See which one of the packages are fiscally sponsored by NumFOCUS. So maybe we go to Boca and go out to NumFOCUS to see if this is a good replacement for what we need, or if there's features we can add to this open source package to fulfill our needs. So there's two stories there for utilities, and all right, we've got some time. So I'm going to try to find the paper. You know what? It's only one paper. And I'd have to, I think I remember which one it was. But I haven't coded the paper connection yet. All right, so we'll ignore the paper thing for now. But one interesting thing I did just map the other day, move all our connections. And let's connect everything to subfields. So let's say I'm a researcher and I just need to visualize some data for my research. So I just mapped the visualization little ecosystem. So I now see the subfield visualization, and I see all of these packages are related to visualization in some way. And what we'll be able to do in the future is, I wonder if it works now. It sort of does. Okay, so I search for a tag, dashboarding, and it looks like I can use JupyterFlex for dashboarding. In the future, I'm not sure if it's possible with Kumu, but in the iteration where we're building this outside of Kumu, what we'd want to happen there is only the nodes that are for dashboarding would appear and everything else would disappear. So the user could find all the packages for dashboarding, and then there would be more information here to help guide them to the correct tool or the most appropriate tool for their specific use case. And you can think of LLMs as they start to develop more and be able to interact with graph databases. If I just type in natural language, hey, I need to visualize this data and build a dashboard for it, and I'm working in Python, and I'm working in geology or something like that. The LLM will be able to scan the graph and give us back some good use cases, some good packages, some good tools to use for our specific use case. That's going to be very neat when that gets built in. That's not anywhere in the short-term roadmap though. So this is Moss. Those are a couple stories going very quickly into what we hope the capabilities of this map will provide. The papers aspect of it will hopefully tell another story besides a researcher looking for a tool to use in the research, or someone who's found a security flaw looking for who to contact and possible dependency implications and possible alternatives. And this third story will be impact of a tool. A lot of these open source tools have DOIs and can be cited, and despite it not being as much as we would hope, they are cited. And so we want to map all the papers that cite these specific tools so that we can visualize the paper impact, and whether or not that's technical impact or not goes into the metrics definitions that we're also exploring, which are very fun conversations that everyone is invited to join. But we'll be able to visualize all the papers that come out of these tools, and then all the products that come out of those papers, and we'll really be able to see and show how important, how foundational open source research software is to society at large. Not just research, but to everything. You know, and to bring in LLMs again, because they are still very hype, a lot of these packages and tools are foundational to AI and LLM. So we need to show that in this map so that funders and supporters of open source research software, open source software in general, understand how their funding impacts the world around them, and then can also use that to show off how impactful they are in the world. Hopefully, if we start mapping citations as well, and then the people connected to the papers that are citing this open source software, those people who are incentivized by citations and social reputation and social graphs will be more incentivized to cite this open source software, because every time they cite a paper, they get put on this map and their circle grows bigger. They're more easily identifiable on the map simply because they cited the software they're already using. So there's a lot of downstream effects we hope mapping this system and making it a visual and an interactive visual have. Because one of the hopeful outcomes of this development is that it will be an entirely composable map. So whatever I want to do with the database that's visualizing this map, I can do it. Depending on my context, whatever my context is with regards to the open source research software ecosystem and what I need to find, there will be this database that is managed by a commons or the open source ecosystem. And I can visualize that database however I want and explore it through LLMs or whatever other means I desire. So before we get into Q&A or any discussions, I want to start trying to map the entire ecosystem just so we can see how powerful the visualization is. I'm trying to think of the best way to do this without crashing my computer. So I'm going to show people, but I'm only going to show people who have committed to these open source repositories more than 10 times. And this highlights, the fault of one of the metrics we're using, which is the size of these people circles as determined by the number of commits they've made to the repos, to the projects we're mapping. That's obviously not a good indicator of contributions to these projects. It actually excludes a lot of originators of the packages and the projects. But it is an easy way to start mapping this stuff and also control how many of these circles show up so that when we start drawing the lines, again, the computer doesn't crash. So let's map people to projects. Let's see what that looks like. Okay, hard skip a beat there. Very cool. Let's do the easy one here. Projects to fiscal sponsors. Yeah. We might freeze. If we freeze and I disconnect, Tim, please take over. Okay, let's map packages to projects. So packages to projects, for example, is good for projects like AstroPy, which is a collection of a lot of packages, and in itself is not necessarily a singular package or tool, but it is a singular tool, it's a singular project, but it's comprised of many different packages. Now let's map projects to sustaining and parent orgs and packages to sustaining and parent orgs. And the only little sub-ecosystem that has been mapped with these is the visualization section I just added. So let's actually see if we can see, yeah, you can see all these organizations out here support open source visualization in some way. And one of the most interesting ones I found so far, if we can find it, Snowflake, Spotify. Spotify has supported open source research or open source visualizing tools at some point, which is really interesting. I'm looking forward to talking to them and figuring out why, what else they're doing, and how we can get them to support more open source software. Because look, they're on the map because they supported open source research software in some way. Okay, we're starting to see this map take place or take shape here. Let's map people to packages, and I think we'll stop there. And as this renders, oh no, come on, you can do it. Woo! Happy to take any questions if anything has come in. Or happy to just have a discussion as well if anyone has any thoughts. I'll throw up the QR code again at the end. And I will also say that this is very much a community initiative. We're leading it out of OSI. It's largely me and Tim building this thing. We have two other people who are helping build us, Mark and someone else who's just joining us. We have working groups. We have the interest group, which meets once a month for just a discussion on overall strategy, direction, what we're doing, how we're doing it, that sort of thing, knowledge sharing. And then we have a working group that meets once a week. And we just work on this thing, talk about any problems that we're having as we're building it. For example, being able to map papers came out of that working group where we just sat down and found the DOIs for every package we've mapped so far. If you work with a tool just that's not on the map, you can just reach out to me or to him, and we will do our best to add it as we build this thing out. We are prioritizing proof of concepts of each story along the way. And because we are using Kumu, which is very, very good for smaller visualizations, but it starts to get limited in capability as we get bigger. We're going to have to choose what we add to this map just so we can be sure we can tell all these stories with this proof of concept. I can keep talking unless there are any questions. Tim, did anything?
Yeah, thanks so much. This is great. I'm answering questions in the Q&A. I'm answering them. For example, where can I use this? An app yet that's ready for starting to prototype this year. Another question.
What I'll add to that is we are looking into licensing so that we can, because this is Kumu, you can see up here it's private. We want to make it public so people can start playing around with it. The issue is licensing it so that we keep it under NumFOCUS. And hopefully we will be able to release this Kumu map, which is completely interactive for anyone who wants to play with it. You can see the database and all of that sometime early next year, but don't hold me to that. Hopefully soon.
Yeah, another question was whether this is only Python project. It is not. We're not limited to any particular programming language. As long as it's related to science, we want it on the map.
Yep, and I'll map languages here for a second. So the reason it is a lot of Python projects right now is because a lot of NumFOCUS fiscally sponsored projects, which is where we're starting, are Python projects. But there are a couple R and Julia projects on here as well.
Somebody asked what tool we're using, and I mentioned we're using Kumu. We love Kumu. This has been awesome to get us this far and to just play with some of these ideas and concepts. And I hope that if you use your imagination, you can see where it lead. Once it gets onto like a real like a solid app that supports you know, advanced search and analytics and visualization tools. And so yeah, hope that.
And I will point out, if anyone's interested in getting involved, we are on that architectural level, we're exploring Neo4j as a possible language and backend to build this outside of Kumu. So if you know Neo4j or comfortable with it, please reach out. Love to talk.
Somebody just asked how and obviously, I think we're hitting the limits really hard of what Kumu can support. I've never seen a Kumu map with this many, you know, nodes in it. So it takes a while for these things to render in Kumu. However, in the future, I think once we have an actual, you know, standalone app with a proper architecture, I think we will be able to solve those issues.
Yes, we expect millions, if not hundreds of millions of nodes at some point. Because think about the open source research software, and then this is still people who have fewer than 10 commits. So I'm going to click. This might actually crash. I'm just going to click everyone and see what happens. Oh my God. It's so cool to see. I love it every time. You can see, start to see just how useful this messy, seemingly messy visualization of the graph of the ecosystem is. As we start to put in more metrics, you see this person has done a lot for something, you know, and we can click that node and explore what. See, this organization, which I just happen to know is NumFOCUS, seems to be an anchor for this little section of the map, at least. These projects out here seem to be very niche. Everything in here seems to be fairly core to what's going on in open source research software. And as we build more organizations and little microcosms of the larger space in here, there's only going to become more useful. I'm very excited for what happens as we keep building this out. All right, so I'm going to
Hi, Jonathan. Looks like we have time for just one last question.
Sure.
Let me bring a question for you on screen.
Vertices and edges. Yeah, I was just talking about that. It's going to be very large. Like right now, it's I think 10,000 nodes ish, plus or minus 3,000. And then connections wise, it would have to be a complete guess, but I would guess 30 to 50,000. Complete guess though. It's hard to, because the way the database is formatted, it's difficult to just look at the cell number. But if there are any more questions, or if you want to get involved, please do out John, Jon, at numfocus.org. Scan this QR code. That'll take you directly just to more links. You can learn more about OSI, because we do other stuff besides MOS. And I do invite you to join, because this is a community. We're trying to build this as best we can with this community. We want input. We want your help building it.